What if I told you that something from another star system is currently firing a massive jet straight toward our Sun? What you're about to learn about the interstellar comet 3I Atlas will completely change how you see the universe beyond our solar system. Get ready. This revelation is more unsettling than you might imagine. Something is crossing our solar system that doesn't belong here. The comet 3I Atlas, discovered in late June and confirmed by NASA in early July, is the third interstellar object ever detected by humanity. But don't think this is just another ordinary comet drifting through space. This alien visitor has features that even the most experienced scientists find baffling. With a width somewhere between 5 and 11 kilometers, 3I Atlas is the largest interstellar object ever to cross our path. To put that in perspective, imagine a mountain the size of Mount Everest traveling through space at unimaginable speeds. But its size is far from the most disturbing trait. The real question keeping astronomers awake at night is, where exactly did it come from? 3I Atlas originates from a completely unknown star system far beyond our solar borders. NASA and European Space Agency scientists have been working tirelessly to trace its path back to its origin. But so far, the starting point remains an absolute mystery. What makes this even more fascinating is that this comet may be older than our own Sun. That's right, you heard correctly. While our solar system is around 4.6 billion years old, evidence suggests that 3I Atlas could be billions of years older, making it a relic from the early cosmos. Dr. Michael Brown, astronomer at the California Institute of Technology, explained in a recent statement that interstellar objects like 3I Atlas act as space-time capsules. They carry information about conditions in the universe before our planetary system even formed. Each observation offers a unique window into understanding not just where it came from, but how galaxies and star systems evolve across billions of years. The discovery of 3I Atlas marked a historic moment in modern astronomy. Before it, only 2 interstellar objects had ever been confirmed: Oumuamua in 2017 and Comet Borisov in 2019. Each of those visitors brought more questions than answers. But 3I Atlas is different. Its massive size and unique characteristics put it in a league of its own. What makes some researchers particularly uneasy is the comet's strange behavior. A small but vocal group of scientists has proposed a controversial hypothesis. What if 3I Atlas isn't just a natural comet? What if it's actually some sort of probe or alien craft sent to observe our solar system? Although this idea is widely dismissed by mainstream scientists, it raises deep philosophical questions about what we truly know regarding objects that come from beyond our cosmic neighborhood. Nonetheless, astronomical evidence still points to a natural origin. The comet AS chemical makeup and movement patterns match what we expect from a genuine interstellar comet. But the story becomes even more intriguing when we look at what has been discovered recently about this mysterious visitor. On August 2nd, something extraordinary was reported. The twin 2-meter telescope at the Teide Observatory in the Canary Islands, Spain, captured images showing a stunning phenomenon. 3I Atlas is releasing a gigantic jet of gas and dust directly toward the Sun. This isn't just a casual observation. It's a revelation that confirms behavior scientists suspected, but had never seen so clearly in an interstellar object. The composite image, created from 159 individual 50-second exposures, shows the comet's icy core as a dense, dark point surrounded by a bright, mysterious halo. What really draws attention, however, is a sudden fan-shaped break in that bright ring. It's precisely at that spot that researchers identified a massive jet of material being ejected at extreme speeds, aimed squarely at the Sun. Miquel Serra Ricard, astronomer at the Canary Islands Institute of Astrophysics and one of the lead researchers behind the discovery, explained that this behavior is consistent with cometary activity seen in comets from our own solar system. When a comet approaches the Sun, the intense heat causes the volatile ices on its surface to sublimate, turning directly from solid to gas without becoming liquid, creating jets that shoot out at hundreds of meters per second. What makes this observation especially significant is the phenomenon's scale. Sarah Ricard estimates the jet extends roughly 10,000 kilometers from 3I Atlas's surface, almost Earth's full diameter. Picture a plume of material being blasted through space on that scale, and you begin to grasp the astonishing magnitude of what we're witnessing. Spectrographic analysis reveals that the ejected material is composed mainly of dust particles and carbon dioxide, echoing earlier findings from the James Webb Space Telescope in August. The JWST, humanity's most advanced space telescope, confirmed a large gaseous envelope around the comet, evidence of a temporary atmosphere rich in volatile compounds. Dr. Jane Richardson, a physicist specializing in comet dynamics at the University of Arizona, noted that jet formation in comets is one of the most dynamic and visually spectacular processes observable in our solar system. As the comet's core rotates, the jet doesn't stay fixed. It sweeps through space like a cosmic lighthouse, creating fan-shaped patterns detectable by ground and space telescopes. This behavior isn't unique to 3I Atlas. The famous comet Neowise, which captivated the world in 2020 when visible to the naked eye, also produced spectacular fan-shaped jets near the Sun. Observations from the Hubble Space Telescope documented those jets in stunning detail, providing a useful comparison for what we're seeing now with 3I Atlas. Images from the twin 2-meter telescope were shared on the Astronomer's Telegram website on October 15th, immediately drawing global attention from the astronomy community. Though the data hasn't yet appeared in a peer-reviewed study, the observation quality and the observatory's credibility lend substantial weight to the preliminary findings. To truly understand what's happening with 3I Atlas, we must dive into the fascinating physics behind cometary jet formation. This process may seem alien, but it's governed by well-understood physical laws, showing how nature operates on cosmic scales. When a comet drifts through deep space, far from any star, it remains mostly dormant. Its surface composed of various frozen elements like water ice, carbon dioxide, methane, and ammonia, all kept near absolute zero temperatures. As it nears a star like our Sun, everything changes dramatically. Solar radiation begins heating the comet's surface. The warming isn't uniform. Different regions absorb varying amounts of sunlight based on their composition and orientation. When a given area reaches a critical temperature, volatile ices sublimate, releasing gas and pressure that form jets shooting out at hundreds of meters per second. Dr. Paul Weissman, planetary scientist at NASA's Jet Propulsion Laboratory, explains that jet formation depends heavily on a comet's internal structure. Not all surface regions sublimate evenly. Jets often emerge from areas with higher concentrations of volatile materials or porous structures that let trapped gases escape through natural vents, essentially acting like rocket nozzles. In 3I Atlas's case, its jet happens to point directly toward the Sun. At first glance, this might seem counterintuitive. You'd expect material to be blown away from the heat source. But the jet's direction is defined by the comet's surface geometry and by where active regions are located on its rotating core. The material follows the path of least resistance, which can easily point sunward depending on the comet's orientation. Yet the physics grows even more fascinating. While the jet initially moves toward the Sun, the fate of that material is much more complex. Some of it becomes trapped within the comet Nautoriki, bright cloud of gas and dust that forms a temporary atmosphere. This coma can stretch hundreds of thousands of kilometers, creating one of nature's most breathtaking spectacles. At the same time, other material is pushed away from the sun by solar radiation pressure and the solar wind, a constant flow of charged particles emanating from our star. This interaction forms the comet's iconic tail, which always points away from the sun, regardless of its travel direction. That's why comets can simultaneously have jets aimed toward the sun and tails pointing away, without violating any physical law. Dr. Karen Meach, astronomer at the University of Hawaii and a leading expert in interstellar objects, emphasizes that understanding cometary jet dynamics is crucial, not just for studying individual comets, but for tracing the history of our solar system itself. The gases released by these jets reveal clues about conditions in the distant regions of the protoplanetary disk from which our system emerged. In 3I Atlas's case, spectroscopic analysis shows signatures of carbon dioxide and silicon dust, typical of comets formed in cold regions of other star systems, where extreme temperatures allow light gases to become part of the core. The presence of these compounds strongly supports that 3I Atlas is a genuine comet, not an artificial object. 3I Atlas's journey through our solar system has been nothing short of epic. This interstellar visitor isn't just passing through, it's actively interacting with planets, moons, and the sun, in a cosmic dance offering scientists an unprecedented chance to study an object from another star system in extraordinary detail. On October 3rd, 3I Atlas reached a major milestone, passing close to Mars, the Red Planet. This encounter wasn't just an astronomical coincidence, it provided a unique opportunity for observation. Martian orbiters, such as NASA's Mars Reconnaissance Orbiter and ESA's Mars Express probe, captured privileged views of the interstellar comet from angles impossible to achieve from Earth. Those orbiter images revealed fascinating details about the comet's coma and potential tail fragments. Dr. Roberto Orossi, planetary scientist at Italy's National Institute for Astrophysics, noted that multiple observation platforms positioned throughout the solar system enable triangulation and 3D analysis of the comet's structure, something ground-based telescopes alone can do. But 3I Atlas's journey was far from over. After its Martian encounter, the comet continued on its hyperbolic path toward the sun, drawing ever closer to our system's greatest source of heat and radiation. The critical date, October 29th. That's when it reaches perihelion, the point of closest approach to the sun. Perihelion is the most dramatic event in any comet's life. As 3I Atlas nears this moment, the intensity of solar radiation bombarding its surface increases exponentially. NASA scientists estimate the sunlit side could reach hundreds of degrees Celsius, a shocking contrast to the cryogenic temperatures it experienced for billions of years in deep space. This intense heating will cause spectacular consequences. Sublimation rates will spike, potentially producing new jets or expanding existing ones explosively. The comet's coma could grow to truly astronomical sizes, rivaling giant planets, while its tail might stretch tens of millions of kilometers across space. However, major risks accompany this process. Some comets don't survive their perihelion passage. The thermal stress and gravitational tidal forces from the sun can shatter fragile nuclei. The famous comet Ison, once hyped as the comet of the century, disintegrated spectacularly during its perihelion in 2013, leaving only scattered debris behind. Will 3I Atlas survive? Dr. Matthew Knight, astronomer at the University of Maryland, is cautiously optimistic. He points out that the comet's substantial core size, estimated between 5 and 11 kilometers wide, suggests a sturdy structure likely to remain intact. Plus, its early intense activity signals abundant volatile materials, implying a solid, cohesive nucleus. Right now, 3I Atlas lies on the far side of the Sun from Earth, making it invisible to ground observers. This creates a kind of cosmic suspense. For weeks, we won't know how it's behaving, or whether it's surviving the solar onslaught. Only when it reemerges on the Sun's opposite side, expected in mid-November, will astronomers assess what's changed. Dr. Michelle Bannister, planetary astronomer at the University of Canterbury in New Zealand, calls this waiting period one of the most exciting and frustrating moments in modern astronomy. We have an extraordinary interstellar object going through the most critical stage of its journey through our solar system. Yet we can observe it directly because of the Earth-Sun comet geometry. When 3I Atlas reappears in mid-November, humanity will have a historic, and perhaps once-in-a-lifetime, chance to witness the transformation of an interstellar visitor after its encounter with our Sun. This isn't just another routine observation. It's a natural experiment on a cosmic scale that could uncover fundamental secrets about comets, planetary diversity, and even the origins of life itself. Scientists have a long list of questions they hope to answer. The first and most obvious: did the comet survive intact? If so, how drastically has its appearance changed? Has the giant jet discovered in August grown even larger? Did new jets form? Has the tail stretched to record lengths? These are the questions keeping astronomers around the world in eager anticipation. Dr. Alan Fitzsimmons, astrophysicist at Queen's University Belfast, explains that post-perihelion observations are critical to understanding comet evolution. By comparing 3I Atlas's state before and after its close pass, scientists can measure how much mass was lost, how volatile material redistributed, and whether the core stayed stable or fractured. But the implications go beyond physical change. 3I Atlas offers a glimpse into conditions from other star systems billions of years ago. Each chemical reading gives clues about materials that existed during the formation of its native system, information that feeds galactic-scale models of planet formation and chemical evolution. Dr. Bonnie Bharati, planetary scientist at NASA's Jet Propulsion Laboratory, highlights that interstellar comets are especially valuable because they let us compare materials formed under entirely different stellar conditions. By contrasting 3I Atlas with native solar system comets like Halley or Hale-Bopp, scientists can identify universal similarities and revealing differences that reflect unique cosmic nurseries. There are profound implications for astrobiology, the study of potential life beyond Earth. Comets are thought to be major carriers of complex organic materials throughout planetary systems. During the late heavy bombardment around 4 billion years ago, countless comets crashed into rocky planets, possibly delivering not just water, but essential organic compounds, the ingredients for life. If interstellar comets like 3I Atlas also contain complex organics, it suggests that life's building blocks are spread universally across the galaxy. This concept, known as panspermia, proposes that life or its precursors may travel between star systems on objects like comets. 3I Atlas might literally be carrying molecules formed around a completely different star, offering a humbling glimpse of our broader cosmic connection. Telescopes worldwide, both terrestrial and space-based, are already scheduling intensive new observations once the comet reappears. The James Webb Space Telescope, with its unparalleled infrared sensitivity, will search for specific organic molecules in the comet's coma. Hubble will capture high-resolution images of its jets and nucleus. Ground-based observatories like the Very Large Telescope in Chile and the Keck Observatory in Hawaii will perform detailed spectroscopy to map its chemical structure. Dr. Carrie Leese, astrophysicist at Johns Hopkins University's Applied Physics Laboratory, notes that we're living in a golden age for studying interstellar objects. The combination of advanced telescopes and sophisticated detection algorithms is dramatically improving our ability to find and analyze these rare visitors. He predicts that in the coming decades, we'll discover dozens or even hundreds more, turning what is now a rarity into a regular field of scientific inquiry. What makes 3I Atlas especially remarkable is its timing. It arrived at a moment when we finally have the technology to study it in unprecedented detail. Just a decade ago, many of the tools we're using didn't exist. In the future, when more interstellar objects become common discoveries, 3I Atlas will be remembered as one of the first thoroughly studied examples, setting paradigms and methods for years to come. So, what happens after its passage through our solar system? Eventually, 3I Atlas will be flung outward by the sun's gravity, escaping forever into interstellar space. It will travel for millions or even billions of years until perhaps entering another star system someday, where other intelligent civilizations might observe it and wonder about its origins, just as we do now. 3I Atlas is more than just a comet. It is a message from the universe beyond our small cosmic corner. Every observation, every measurement, every captured image brings us closer to understanding not only this mysterious visitor, but also our own place in a vast, interconnected universe. If this discovery fascinates you as much as it amazes us, subscribe to Secret Universe so you don't miss any updates about 3I Atlas and other shocking cosmic revelations. Leave a like to support our work in bringing these universe secrets to you. And in the comments, tell us, do you think 3I Atlas will survive its passage near the Sun? What else would you like to learn about this interstellar visitor? Your thoughts matter to our community of cosmic explorers.